Hi and Assalamualaikum. Today we will present to you about work, energy and power. Now I will introduce my group members. Me, Siti Nurdiana binti Muhammad. Second, Nur Akilah Inshirah binti Muhammad Rozi. And the last one, Maizatul Amni binti Manan. We are students from CS 143, Diploma in Mathematical Science. Our course code is MAT272, Introduction to Mechanics. Our course group is CS 143 4D. This video prepared for Miss Mardiah Ismail. Our first topic is work. So, work. What is work? Work is scalar quantity and is defined as the product of an applied force and the displacement of an object in the direction of the applied force. First, work done by a constant. When we see the figure, force and displacement in the same direction. Formula W equal to F multiplied by S. F equal to force, S equal to displacement, unit work equal to joule or Newton meter. The SI unit for work is joule. 1 joule is equivalent to 1 Newton meter. 1 joule is the work done produced when a force of 1 Newton moves toward 1 meter in the direction force. For this figure is when the applied force on an object and the direction of movement of the object is not the same. Calculate work done by using formula W equal to F cos theta multiplied by S. Second, work done against gravity. Mass of mkg vertically at a constant speed. A force of mg Newton must be applied vertically upwards to the mass. In raising the mass a distance of s meter, the work done against gravity will be W equal to mgs, which is g equal to gravity. Third, work done against friction. When a body pulled at a uniform speed on a road surface, the work is done against the frictional force which is acting on the body due to the contact with the road surface. The last one, condition when no work is done. Object is stationary, no force is applied, direction of motion is perpendicular to applied force. So, we need to calculate it using the formula W equal to force multiplied by S. S equal to 0 because no work is done. W will be 0 joule. Question 1. Kalish used a force of 20 Newton to sweep the floor in the class. The applied force made an angle of 36 degrees with the floor. What is the work done by Kalish when she pushed the broom a horizontal distance of 3.2 meters? By using the formula W equal to F cos theta multiplied by S. F equal to force, S equal to displacement. F was given 20 Newton and S also was given 3.2 meters. Theta equal to 36 degree. So just calculate using the formula W equal to 20 Newton multiplied by cos 36 degree multiplied by 3.2 meters. So the answer will be 51.7771 joule. Question 2. Calculate the work done in lifting 150 kg of water through a vertical height of 7 meters using the formula W equal to mgs, m equal to mass of water equal to 150 kg, s vertical height equal to 7 meter, gravity equal to 9.81. Just calculate in the formula W equal to 150 multiplied by 9.81 multiplied by 7. The answer will be 10,300.5 joule. Question 3. A horizontal force pulls a body of mass 3.55 kg a distance of 13 meters across a horizontal surface. The coefficient of friction between the surface and the body is 0.4. Find the work done against friction. From the question, I was draw the figure to make it easy for me to do the calculation. I use the formula F equal to mu equal to 0.4, R equal to 3.55 divided by gravity 9.81. So F equal to 0.4 multiply 3.55 multiplied by 9.81. The answer for F is 13.9302. So, I use the formula W equal to F cos theta multiplied by S. So, 13.9302 multiplied by cos 0 multiplied by 13. I get the answer 181.0926 joule. Question 4. Calculate work done when Adam carrying a bag while walking to the school. I use the formula W equal to F multiplied by S. The applied force is upward to support the bag. Since the condition of the force and direction is perpendicular to each other, therefore, this is no work is done. So, I use the formula W equal to F cos 19 degree multiplied by S. So, W will be 0 joule.
So what is energy? Energy is the ability to do work, which is the ability to exert a force causing displacement of an object. So there's two types of energy that we're going to learn in this topic. The first one is kinetic energy and potential energy. The first one is kinetic energy. So what is kinetic energy? Kinetic energy is the energy that the object possesses due to its motion. For example, moving car and kicking a ball. Okay, so the formula that we're going to use for kinetic energy is 1 per half mv square, which is m is represent as mass in kilogram and v as a velocity in meter per square and kinetic energy as a joules. Kinetic energy depends on mass and speed. From this picture, we know that kinetic energy increases with mass. For example, if the skateboard and the rider are moving faster, it also takes more work to bring them to stop. This means kinetic energy also increases with speed. Kinetic energy is related to both the object speed and its mass. So to be more details, let us look at some example regarding these kinetic energy problems. So look at example 1. A 70 kilogram man runs at a pace of 4 meters per second and a 50-gram meteor travels at 2 kilometers per second. Which has the most kinetic energy? So, in this question, they give us two different situations and they want us to find which one of the situation has the most kinetic energy. Okay, so to solve this problem, we need to find the kinetic energy for each of the situation. The first situation is man runs. Okay, they give us a mass of 70 kilogram and a velocity 4 meter per second. So, they already give us the information. So, just put the mass and the velocity in the formula. So 1 per half multiplied by 70 multiplied by 4 square. So for man, runs, we got 560 joules of kinetic energy. And the second one is meteor travels. They give us 50 grams of mass and 2 kilometer per second. From the previous, I already stated the formula of kinetic energy. The mass is represent as kilogram and velocity represent as meter per square. So in this question, they gave us mass as gram and velocity as kilometer per second. So we need to change the gram into kilogram and kilometer per second into meter per second. So 50 gram equal to 0.05 kilogram and 2 kilometer per second equal to 2000 meter per second. So just put the information that we already know into a formula. So 1 per half multiplied by 0.05 multiplied by 2000 square. So the meteor travel, we got 100,000 joules of kinetic energy. So the question wants the most kinetic energy. So we need to differentiate which of the situation has the most kinetic energy. So the answer is the meteor travel. So next is example 2. A car traveling at 10 meter per second has 200,000 joules of kinetic energy. What is the mass of the car? So this question, they ask us to find the mass of the car. The information given is 10 meter per second, which is velocity, and 200,000 joules, which is kinetic energy. So the information given, just put it into a formula to find the mass of the car. So 1 per half multiplied by mass multiplied by 10 square equal to 200,000. So mass equal to 200,000 divided by 1 per half multiplied by 100. So the mass of the car that we got is 4,000 kilogram. Okay, the second type of energy is potential energy. So what is potential energy? Potential energy is the energy stored in an object due to its position above the Earth's surface. For example, a crane lifting and drawn bow. So the formula for potential energy is M multiplied by G multiplied by H. M is represented as mass in kilogram. G is gravitational acceleration equal to 9.81 meter per second square, and height in meter. So let's do some example for potential energy. Example 1. How much potential energy does a 5 kilogram rock that is 10 meter above the ground has? So in this question, they want us to find the potential energy, which they already stated mass of the rock is 5 kilogram and the height is 10 meter. So we already know the gravitational acceleration is 9.81 meter per second square. So just put all the information given into a formula. So M multiplied by G multiplied by H. M is 5 multiplied by 9.81 multiplied by 10. So the potential energy for this question is 490.5 joules. Okay, so for the example 2, a helicopter is flying at a height of 1.5 kilometer. If it has 50 megajoules of potential energy, what is the mass of the helicopter? So in this question, they want us to find the mass of the helicopter. They already stated the height of 1.5 kilometer and 50 megajoules of potential energy. But in this question, they give us a height in kilometer and potential energy in megajoules. But in the formula, it's already stated that the height must be in meter and the potential energy must be in joules. So we need to exchange the height from the kilometer into a meter and megajoules into a joules. So 1.5 kilometer equal to 1,500 meter and 50 megajoules equal to 50 million joules. So to find the mass of the helicopter, just put all the information that we already know into a formula, which is 50 million equal to m multiplied by 9.81, which is gravitational acceleration, multiplied by 1,500. So the mass of the helicopter is 3,397.89 kilogram. So the last example for this topic is example 3 is about a boy throws a 0.2 kilogram rock up with a speed of 5 meters per second. If all the kinetic energy becomes gravitational potential energy, how high will the stone go? So for this example, it have two different type of energy, which is kinetic energy and gravitational potential energy. So in this question, they want to know the height of the stone. So 1 per half mv square, which is the formula of kinetic energy, equal to mgh, which is the formula for potential energy. So we already know a mass, which is 0.2 kilogram, and a speed 5 meter per second. So from the information given, we can know the kinetic energy. So 1 per half mv square equal to 1 per half multiplied by 0.2 multiplied by 5 square. So the kinetic energy that we got here is 2.5 joules. Okay, since they want to know the height, so we need to find the potential energy. So they state here the kinetic energy equal to potential energy. So mgh equal to 2.5. So 0.2, the mass, multiplied by 9.81, the gravitational acceleration, multiplied by height equal to 2.5. So height equal to 2.5 divided by 0.2 multiplied by 9.81. So the height of the stone that we got here, 1.27 meter. So that's all the explanation about the energy.
Let me move to our last subtopic, which is about power. What is meant by power? Power is the rate at which work is done and is measured in watt. Watt is the SI unit used in power, and we can write as a capital letter of W. The formula used here is power equal to work done over time. We should calculate work done over with time because we are calculating the rates of work. As for the illustration below, we can see that someone is pushing a block with some force in 3 seconds, and the distance when he pushed the block is about 5 meters. So this means when we are calculating the power, we should have the distance, force, and time. But The distance is not in the power formula. This is because we are using distance in work done formula, which is the force must be multiplied by distance. Now, let me move to our question section. For our first question, the question stated that a lift in a hotel can raise 8 people through a height of 20 meters in 5 seconds. The lift plus passenger has a mass of 800 kilograms. What is the power of the lift motor? So, firstly, we should calculate the work done by multiply the force and the distance. But
We should change 800 kilogram into Newton.
which is 800 must be multiplied with 9.81 and multiply it with the distance. So the answer will be 156,960. So next we proceed to calculate the power, which is divide the work done with 5 seconds. The last answer will be 31,392 watts. And don't forget to put the SI unit. Next, a car that is moving at a speed of 10 meters per second. The force of the car is 100 Newton and distance traveled is about 10 meters. The time to travel the distance is 2 seconds. Therefore, state the power of the car. Calculation is the same as the previous question, but in here, the work done should not be multiplied with 9.81 because the force is already given, which is in Newton, so that you must calculate 100 multiplied with 10, which is the distance. And the answer will be 1000. 1000 must be divided by 2 and the last answer will be 500 of watt. Question 3. Amir can lift a 200 Newton weight over a distance of 2 meters in 5 seconds. And Mutu also do the same work just in 1 second. Count each power produced by Amir and Mutu. Here we are calculating the same thing but the difference percent with the different time. For Amir, 200 Newton must be multiplied with 2 meters and divided with 5 seconds. The answer will be 80 watts. While Mutu, the power produced by him is 400 watts. So, we can conclude that the lower the time, the higher the power produced. This is our last question that talk about an ice cube is pulled by a force of 20 Newton at an angle of 60 degrees to the smooth surface for a displacement of 150 centimeters about 5 minutes. Calculate the work done and the power. Work done here, we should change to another formula which is F cos theta multiplied with distance, which is 20 cos 60 degree multiplied with 1.5. The answer of work done is 15 joule. Next, we move to calculate the power. By 15 divide with 5 and the last answer for the power is 3 watts. As a conclusion, we can conclude that work, energy and power are closely related concepts in our daily life. Firstly, work is meant by the transfer of energy from one system to another system. Then, energy is the ability to do work and comes in different forms such as kinetic energy, potential energy, and thermal energy. Lastly, power is the rate at which work is done. A good understanding of this concept can help in analyzing and designing various systems, from simple machines to complex systems such as power plant and engines.
And there exist many kind of formula to calculate work, energy and power. So that's all from us. Thank you.